Project, and our topic is hate speech detection. Introduction. The proliferation of social media enables people to express their opinion widely online. At the same time, online hate such as abusive language, insults, personal attacks, etc., has been identified as a major threat on online social media platforms. Here, we undertake the development of an online hate classifier which detects hateful comments in Twitter. Problem statement. Hate speech creates tension between groups of people. Its impact can create serious real life conflicts. For such reasons, websites such as Facebook, YouTube, and Twitter prohibit the use of hate speech. Therefore, in the research field, hate speech has been subject to some studies trying to automatically detect it. Literature review, deep learning, support vector machine, logistic regression, BERT. Deep learning. A supervised learning method is used to detect hate, classify tweets into three or four classes based on tweet sentiment and other features that a tweet demonstrate. Hate speech classifier has 5 steps. First, feature embedding, filter, feature map for each region, max pooling, and soft function classification. The feature embeddings were produced by concatenating the word embedding with this character and gram vectors. In addition to the vector word embeddings, length 28, 1 hot character and gram vectors were generated with 26 elements for the English alphabet, 1 for digits and 1 for all characters or symbols. A pooling layer in the network converts each tweet into a fixed length vector, capturing the information from the entire tweet. A max pooling layer then captures the most important latent semantic factors from the tweets. On the output side, a softmax layer calculates the class probability distribution for each tweet and assigns the hate speech classes or labels based on the probability values. Support vector machine. SVM performs classification by finding the hyperplane that differentiate the classes plotted in a n-dimensional space. An SVM model is basically a representation of different classes in a hyperplane in multi-dimensional space. The hyperplane will be generated in an iterative manner by SVM so that the error can be minimized. The goal of SVM is to divide the datasets into classes to find a maximum marginal hyperplane. Each type of feature is fitted with the individual linear SVM classifier, creating a view classifier for those features. Combining SVM with different classifiers provides improvements to various data mining tasks and text classification. On the output side, calculate the accuracy and F1 score for different datasets. Here, we have experimented with a system for hate speech detection based on a machine learning support vector machine. It will evaluate the performance on various datasets. Logistic regression. Logistic regression LR is a supervised learning classification algorithm used to predict the probability of a target variable. The target or dependent variable will have only two possible classes. The probability of an output is calculated by the linear combination of independent or predicted values. The logistic or sigmoid function is represented by an S-shaped curve that assigns values between 0 and 1. The next step is to transform the calculated probabilities into binary values. This is achieved by using the logistic function, which limits the range of outputs between 0 and 1. The choice of logistic regression is supported by its simplicity and common use for text classification.
Good evening, teachers. I am Najia. BERT. BERT makes use of transformer and attention mechanism that learns contextual relations between words in a text. With BERT, each word of a comment is transformed into a vector of size. A comment consists of multiple words, then forms a matrix where n is the number of words in a comment. There is less than n words as BERT inserts token at the beginning of the first sentence and a token at the end of each sentence. BERT uses a tokenize to split the input text into a list of tokens that are available in vocabulary. It learns words that are not in the vocabulary by splitting them into subwords. Then load the BERT model, BERT tokenizer, and BERT base uncased pre-trained words weights. Then it transforms each comment into a two-dimensional matrix. It tokenize, pad, and convert comments to phytode sensors. It uses BERT to transform the text to embeddings. Then the comment transformed into word embeddings with BERT. Here is a comparison between different machine learning models. Convolution neural network CNN. It can automatically extract useful features from a simple input feature representation. It can convert categorical data into numerical. Support vector machine SVM. SVM handles outliers better as it derives maximum margin solutions. Hinge loss in SVM outperforms log loss in LR. LR logistic regression. LR have convex loss function, so it won't hangs in a local minima. LR outperforms NN when training data is less and features are large. BERT. BERT is used as an encoder, whereas CNN is used as a decoder. It requires positional and segment embeddings. Modules. The different modules in our hate speech detection is text preprocessing, feature extraction, training, testing, and evaluation. Modules. Input dataset, text preprocessing, feature extraction, classifier, evaluation, and output. Dataset. One of the issues in hate speech detection is the data availability. The dataset contains the Twitter comments and the label where it is classified as hate or non-hate. Text preprocessing. Text preprocessing is the process of discarding noise and useless artifacts. It has two steps, text parsing and text filtering. In text parsing, text is reduced to lowercase and punctuations, numbers and white spaces are removed. Text filtering. Finding root word of the text by lemmatization and stemming. Text preprocessing. Remove numbers, remove punctuations, remove white spaces, tokenization, stemming, and lemmatization.
Good afternoon all. I am Tirtha from CSE department. Feature extraction. It consists of collecting features from the input data and generating informative and non-redundant properties in order to improve the learning and generalization tasks of the machine learning algorithm. Two major approaches for feature generation are bag of words and term frequency inverse document frequency. Term frequency inverse document frequency is an information retrieval technique that weighs a term's frequency and its inverse document frequency. Each word or term has its respective TF and IDF score. The product of the TF and IDF score of a term is called TF into IDF weight of that term. Higher the TF IDF score, the rarer the term, and vice versa. For a term T in a document D, the weight WTD of the term T in document D is given by WTD is equal to TFD D log n divided by DFT. Classifier training. It involves the algorithm which is used in our system. Here we use random forest algorithm, which is a collection of decision trees. Decision tree is a tool that uses a tree-like structure and chance of event outcomes. It follows a set of if-else conditions, visualize the data, and classify according to the conditions. So we take data randomly from the dataset and is fed to the decision trees. For all decision tree, there will be an output. From that, the majority output is taken as final output. Testing is a process for analyzing the performance in terms of precision or accuracy of the model. The model can then be evaluated using confusion metrics. It is for the performance measurement. Each row of the matrix represents the instance in a predicted class, while each column represents instances in an actual class. This is the representation of confusion matrix. Evaluation also gives the values precision, recall, and F1 score. Precision, TP divided by TP plus FP. Recall, TP divided by FP plus FN. F1 score, precision into recall divided by precision plus recall. Accuracy, TP plus TN divided by TP plus TN plus FP plus FN.
Good afternoon. I am Anjali. This is the code of our hate speech detection model. Here we can see in the first step we imported the dataset and it is shown here. The dataset is a Twitter dataset with two classifications, hate or non-hate. Then the next step is removing special characters, hashtags, numbers, URL, etc. Then it is tokenized using NLTK. NLTK is a leading platform for building Python programs to work with human language data. Then the stop words are removed and perform stemming. Here is the Twitter comments and processed tweets. Here in the processed tweets, label is not there. So we want to merge that also. In the next step, the pipeline is used to assemble several steps that can be cross-validated together. Then the dataset is divided into training and testing set. Then it is fit to the model. And the model is tested using predict and determine the confusion metrics F1 score, precision, recall, and accuracy. Conclusion. As hate speech continues to be a societal problem, the need for automatic hate speech detection systems becomes more important. We presented the current approaches for this task as well as a new system that achieves reasonable accuracy. We also proposed a new approach that can outperform existing systems at this task with the added benefit of proved interoperability. These are the references and thank you.